An altimeter is an instrument used to measure the altitude or height of an aircraft above a given reference point, usually mean sea level, MSL. It is an essential instrument in aviation and provides vital information to pilots for navigation, terrain clearance, and maintaining safe altitudes during flight. Altimeters work based on the principle of measuring atmospheric pressure changes with altitude. The instrument consists of a sealed chamber or aneroid barometer that expands or contracts in response to changes in atmospheric pressure. As the aircraft climbs or descends, the atmospheric pressure changes, and the altimeter's mechanism translates these pressure changes into corresponding altitude readings. Here's a brief overview of how altimeters function. Pressure measurement. The altimeter measures the atmospheric pressure at the aircraft's current location. This pressure is known as the static pressure, and is obtained through a static port connected to the instrument. The static port is usually located on the aircraft's fuselage or wing, away from areas of disturbed airflow. Reference setting. To ensure accurate altitude readings, altimeters are set to a known reference point. This reference point is typically mean sea level, MSL. Pilots obtain the current atmospheric pressure at sea level, known as the altimeter setting, from air traffic control or automated weather sources. They adjust the altimeter's reference setting to match the current altimeter setting. Pressure differential. The altimeter compares the static pressure obtained from the static port with the reference pressure set by the altimeter setting. The difference between the two pressures determines the aircraft's altitude. Altitude display. The altimeter displays the altitude using a dial or digital readout. The display is usually calibrated in feet or meters. When the aircraft climbs, the altimeter detects a decrease in atmospheric pressure, and the altitude reading increases. Conversely, during descent, an increase in atmospheric pressure is detected, resulting in a decreasing altitude reading. It's important to note that altimeters provide pressure-based altitude readings, which may not always reflect the true geometric height above ground or other specific reference points. Factors such as non-standard atmospheric conditions, temperature variations, and instrument errors can affect the accuracy of altimeter readings. Pilots must account for these factors and make necessary adjustments to ensure safe flight operations. To maintain accurate altitude information, pilots regularly cross-check the altimeter reading with other instruments such as vertical speed indicators, GPS navigation systems, and visual references. Additionally, altimeters undergo periodic calibration and maintenance to ensure their accuracy and reliability.